Okay, so at the top of your notes for trig modeling, you're going to see a lot of formulas. I will give you all of these formulas on your test. So you do not have to memorize any of this. The only thing you do have to memorize is what's not given to you. So the shape of a sine graph and the shape of a cosine graph, I expect you to know from memory from our hard work the last 3 days. So someone remind me, where does sine start? The middle. Very good. And then it does, you know, whoops, not that. It's supposed to be curvy. Okay, let's try that again. So sine starts in the middle. And then it goes up to the top and then back to the middle eventually. So what's the difference between sine and cosine? Yeah, cosine starts at your maximum line and then dips down and then comes back up. Ooh, that's ugly. But something like that. So that's the general shape difference. So what's going to happen today is we're going to be looking at trigonometric modeling, which is a fancy way of saying story problems where when you graph them, they end up looking like sine and cosine graphs. So it has that added layer of difficulty where it's a story problem. So we're going to try to make this as easy as possible for you guys. The bad news, though, is because we're in Algebra 2 and we don't have a really good grasp of graphing, like we don't even know what a phase shift is yet, my story problems are going to become very repetitive and maybe a little boring. It's going to be like the same 3 story problems over and over and over again. It's going to be a Ferris wheel, or maybe I'll shake it up and make it a paddle boat wheel. And then it's going to be high tide and low tide of the ocean. And it's pretty much going to be those over and over and over again. So the good news for you on that is if it's repetitive, you're going to eventually just keep doing the same steps over and over again and you'll be good. Okay, so the first set of formulas here tells you how to find B. Your job today is going to be to write the sine and cosine equations. So in order to figure out the equation, you have to know what B is, and you can use either one of these formulas depending on what you're given in your problem. So there's a new word that showed up in this formula. We haven't seen this yet in math, but maybe you've seen it in real life. Frequency. Anyone ever heard the word frequency before? Radio frequency. Very good. When you tune into your channel, the frequency differences are based on the cycles per second of that channel, and that's how your radio can tune into the appropriate channel. Very good. So it has a lot to do with sound and radio waves. Yes, yes. But the idea is a period measures seconds per cycle. A frequency measures cycles per second. So they're reciprocals of each other. If for some reason you have to calculate period, these are the formulas you can use. This is the one we have been using the last couple days. Turns out today we really won't have to calculate period very much. We're actually going to be told the period. We got to calculate B. And okay, so here's where they talk about what frequency is. Again, I'm not going to usually have you calculate frequency. In your formula, you need to find B. Another thing you're going to have to find for me is A, which represents what? It's the amplitude. So you can sometimes just sense the amplitude because of your picture. You can see it goes from, 4 to 8 is an amplitude of 4. But sometimes you're going to want to calculate it, and this is the formula you're going to use. And then the other thing you're going to have to find for me is this plus K off to the side. Do you guys remember? We learned about that yesterday at the end of the hour. It's the vertical shift, which moves the midline. So once you find these 3 things, then you can write your formula. So essentially, that's all you have to do in the question, but we're going to learn that that's not as easy as it appears to be. So before we start talking in terms of a story problem, let's look at a non-story problem that just gives us ordered pairs. So let's graph a sinusoidal function, and then we're going to write the function itself. So when they mean sinusoidal function, at the end of this problem, y'all are going to have to write y equals, and then a times the sine. I think I used the wrong colors. Oopsies, that was green for me, wasn't it? Let me fix that. So the a value is going to go right here, and then it's the sine of the b value is going to go inside. Then they use a variable, either x or t or theta. What variable do you want to use here, guys? Theta. I want to get fancy. That's nice. And then it's going to say plus the k value. Well, in order to find these 3 missing pieces, I think a picture is really going to help you map it out. So in the directions it says you have a maximum at point A and a minimum at point B. So I'm going to sketch in a really ugly skeleton of a sine function. Can you guys talk to me about this maximum here? This guy. It's at the ordered pair pi comma 8. So how far over is it? Pi, very good. And how high up is it? Good, it's up 8. And what about this minimum value down here? How far over is it? 3 pi, very good. And then how low is it? -8, very nice. So let's kind of fill in a few more things on this picture, and then I think we'll talk about the formula next. So this was 0, and then it counts to pi, and then there's a missing value here, and then it counts to 3 pi. So what's in the middle here? Good, 2 pi. So apparently we're counting by 1 pi. Is you sensing that? 1 pi, 2 pi, 3 pi. What's this last guy? 4 pi. All right, sketch it in. Okay, I haven't actually found anything yet. I'm still missing these 3 things. Let's start with, I think the midline is the easiest one to find first. And maybe you guys, whoops, blue, maybe you guys can already tell where the midline is because you can visualize it. What's in the middle of 8 and -8? It's going to be 0. But if you weren't sure, you could use your new little formula for k. It says take your max, add it to your minimum, and divide by 2. Hey guys, I know a lot of you love to use your calculator. That's fine. Just use parentheses around that for me, please. What's 8 plus -8 divided by 2? It is 0. So this midline is 0. The next thing I might find is the amplitude. Can y'all tell? Yeah, it is an amplitude of 8. But if you don't know, you just use your formula. So the amplitude formula is max minus min divided by 2. So that would be 16 over 2, better known as, yep, you guessed it, 8. All right, guys, there's just one more thing you have to find, and that's b. I have never asked you to find b. I've always given that to you from an equation, so we're kind of going backwards now. Now look back at your formulas. How do you find b? 2 pi divided by period. Well, do you know the period? Very good. So he's looking at the graph, and he's saying the entire time it takes for it to go through the sine wiggle is all the way out to 4 pi. So the period is 4 pi. All right, guys, what happens when you take 2 pi and you divide it by 4 pi? You get 1/2. Very good. Ta-da, you're done. 8 times the sine of 1/2 theta, and then you don't have to say plus 0 on the end, but you sure can. So that's what we're going to do today. We're going to start by taking our clues and sticking them on a picture, trying to figure out what's going on, and then going over to 3 different formulas to find the k, the a, and the b. And the exact order of what we just did is how we're going to approach pretty much every question where we have to come up with the equation. So clues, sketch it, label the axes, find k first, then find a, then find b. That would be my prognosis, if you will, for today. All right, let's take a look at number 2. It's very similar in start. You're going to sketch a crude little sine graph. And I know some of you are like, oh, why is she putting it around 0? This one's not going to be at 0 because you're looking ahead. That's okay. Your lines are whatever I say they are because I'm going to label them. Do you guys see any labels on anything? Yeah, me neither. So I think we're good. This maximum, which they said 2 pi comma 1 is the max line. When does it occur? Like how far over is this? 2 pi, very good. And how high up is it? It's up here at 1. And then this minimum, how far, this guy right here, this little guy, how far over is it? 6 pi, good, good. And then how low is it? It's at -3 according to that ordered pair. So let's fill in the other missing axis pieces, guys. It started at 0. The first quarter point, if you want to go back to an old word, is 2 pi. What's this missing one in the middle then? I heard someone say 4 pi. Thank you. So they're counting by 2 pi's. 2 pi, 4 pi, 6 pi. So this last one here must be 8 pi. If I kind of sneak in a sine curve. Ooh, that's ugly. Okay. I think if we look carefully, you guys stumbled upon the period length. What is the period? Period is 8 pi. Okay. You know what we haven't found yet, though, is the first thing I need you to find, is the midline. Help me find the midline. And maybe you can visualize it, and maybe you're like, yeah, not today. Then use the formula. So it's the max plus the min. Use parentheses if you're doing it in one step, and divide it by 2. So that's -2 divided by 2, so it's -1. Then I would go ahead and find the amplitude, and again, maybe you can visualize how far away it is from the middle to the top, or maybe you need to calculate it. So if you're calculating it, it's 1 minus -3 divided by 2. So that's 4 over 2, which is 2. And then the final thing I need you to calculate is b. So I'm going to use our new formula for b, which says take 2 pi and divide it by the period, which is, was it 8 pi? So that reduces down to the fraction 1 over 4. All right, guys, you have everything you need. You have k, you have a, you have b, and I know I have to throw this into a sine function, so here we go. Y equals, first thing I write down is a, so 2, times the sine of 1/4. You want to stick with theta for our variable? You fancy kids today. And then instead of saying plus -1, how would most people write that? -1, very good. There we go. Now, I know usually when I ask you guys to move on in the notes, it kind of gets harder and harder as we go through. That's probably not going to be the case today, simply because they're all very repetitive, and it gets more, it gets a little easier for you every example we do. And I know sometimes when I throw things into application format, so like a word problem, some of you are like, oh man, it's about to get really bad. These actually, I think, help when they're applications because you guys can visualize a Ferris wheel. You can visualize a boat bobbing up and down in the water. If there's no visualization, you have no idea if you're doing this right. So I think we're actually going to see that you like the fact that these are applications for once. So let's take a look at this first example. We have the displacement of a boat in sea level as it moves over the waves. So like think about a boat, if it like gets caught in a wake in the Rock River even, like you visualize it, it goes bobs up and down. So sea level would just be like where it normally is, but like as the wake comes through, it dips down, it comes back up, and it's very sinusoidal in effect. So this time, they actually gave you the formula. And then like every good math application, they just decide to randomly switch out their variables whenever they want. So instead of using y, they're using d to represent the displacement or the height of the boat in water. And then it says 2 times the sine of, inside the sine function, they have this weird b value. Can someone tell me what the b value is? And remember, b is the number in front of the variable t this time. What's the b value inside of this sine function? It's more than just pi. 2 pi. Okay. So when I ask you to graph this is kind of like a question from yesterday. So we're going to start at the midline of, I notice there's nothing off to the side, so we're going to start at a midline of 0. And then your amplitude is how big? 2. So you're going to go up 2 units and down 2 units. It does say that we're going to be moving like in a sinusoidal, so let's stick with the sine function. And they want me to graph the boat's displacement over the course of time. So along this axis here, you might want to write yourself a little note. This is where your time value is going to be written down. So the one thing we haven't figured out yet that we needed yesterday during our graphing lesson was we needed to calculate the period. So let's go calculate the period by using our old formula from yesterday that says take 2 pi and divide it by the b value. So what will happen, guys, when you take 2 pi and you divide it by 2 pi? It comes out to a 1. And because this is an application, let's throw a label on that, guys. 1 second. This is what this problem is meaning. Every time you go through a second, your boat bobs up and down. Zoop, 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 every second. So they want you to graph a 3-second time interval. So starting from 0 seconds, they want you to graph 1 second, 2 second, 3 second. But we just found out it goes through a sine wiggle every single second. So here we go. Can you fit a sine wiggle in between here? Oops, I didn't make it. Pretend. There's 1 second. There's 2 second. There's 3 second. There we go. That's all they wanted you to do. That does not look like a question on the test. The test question is going to be the reverse of this. I'm going to give you some clues and you have to write the equation. So that's what we're going to see on this next question. All right. The height of your water varies sinusoidally. That just means that we can use a sine or even a cosine function. And when you get to pre-calc, you do a lot more of this. So you have some weird functions coming up. But those of us who are in Algebra 2 and this is it, we're just going to be graphing everything with a very basic sine or cosine graph. In fact, I'm going to flat out tell you whether it's sine or cosine on the test. You don't even have to think about it. All right, first clue, it says high tide occurs at 10 feet and occurs at 5 a.m. So this is going to be like one of our maximum point, or it is the maximum point, because it's high tide. And then we have low tide, which occurs, it's 2 feet, and it's 3 p.m. So this is going to be your minimum point. So this is a lot like those first 2 questions where they gave you just a random point A and B, and we had to map it out onto our paper. But we do have the added problem of it being in time. Guys, we use what's called a 12-hour clock when we tell time, and I say it's 3 p.m. But it's actually more mathematically beneficial if you guys use a 24-hour clock like Army time. So in the Army, what do they call 5 a.m.? 500 hours. So I'll just call it 5. What would the Army call 3 p.m.? 1,500 hours. Very good. So because we're going to use Army time, you have to measure the number of hours that have elapsed since midnight. So 3 p.m. would be up to noon is 12 hours plus 3 more hours. Okay. Remember how we're putting time along this axis? I'm going to need you to do that again. So keep that in mind. All right, guys. Just draw in like a really sketchy looking sine function for me. And let's talk about this high tide. This guy right here, this is high tide occurring. What time did it occur?
5 a.m.
Yes, 5 a.m. And did you notice there's a clue right here where it says T is measured in the hours since midnight? That's what allows me to use Army time, because they said that. But if for some reason they don't say that, let's just always agree to use Army time. How high up was this? It was the depth of 10 feet. Very good. Okay, let's talk about this low tide point. What time did this occur? Good. I like that you used 1,500 hours because that will allow me to call this a 15. It wouldn't make sense if it goes 5 o'clock and then back to 3 o'clock on that axis. That wouldn't make any sort of sense. And then what depth of the water was it? 3 feet. Very good. So just like we did on our warm-up questions, I think if you guys can just... Oh, it's 2. Okay, yeah. You said through 2. I said 3. I'm wrong. There we go. 2. So just like we did on our warm-up question, let's fill in the little missing pieces, and I think we'll have everything we need to move on. For instance, if this is 5 hours, we started at 0, right? This is 5 hours. What's this missing one in the middle here? We're counting by 5. So 5, 10, 15, 20. It was important that we got to the end, because what does it mean when you get to the end of your sine cycle? What is this number right here? The end. The length of time it takes for the cycle to complete is called the period, which we know is important to the question. We're just not sure how yet. Okay, I think it's time to start finding things. First thing I would like you to find is that midline K. Maybe you already see it. Maybe you already know what it is. I don't, so I'm going to have to calculate it. So it's max plus min divided by 2. So that comes out to a 6. And now we can find the amplitude, but again, maybe you already see it. It's 4 units up and 4 units down, so the amplitude is going to be 4. But if you're not sure, you can always calculate it. So 8 over 2 is definitely a 4. All right, one more thing and then we're home free. How do you find B? How do you calculate B? 2 pi divided by period. Very good. So for us, that would be 2 pi over 20. I want you to give me the prettiest version of this you can. It's 10 is on the bottom though, isn't it? So it's pi over 10. There's B. Here's A. Here's K. Put them in the formulas and let's be done. Now, a little bit of an extra challenge for you guys. They do not want you to use Y or X or theta. They give very specific variables in this problem. It says use H for the height, excuse me, and use T for the time. So your formula is H equals, all right, the next thing you write down is your amplitude. Find them. You already got them. What is it? 4. Good. This was a, what is it, sine or cosine? Sine. Inside the sine function, next comes the B value, which you just found to be a pi over 10. And then for the variable, they said up here, you must use T. So T. And then one more thing, plus the midline. What was your K? 6. Very good. There's your formula. So the picture was just a visual way for us to lay out all the clues. The picture helps us create the formulas. And then once we have the A and the K and the B, everything just gets placed into the formula where they belong. Okay? That's a very typical question of what you will see on your test. In fact, that almost exact that question is on your test next Wednesday. And then there's a question just like that on your post-test, which is like half your final. All right. Oh, this is a fun one. We got a paddle wheel. So we're talking like those gigantic river boats, and they have those huge wheels, those ones that are in the back. And I know some of you don't ride paddle boats, so you're not really sure, but think about it, guys. Where is the wheel located? Like, is it all submerged underwater? Is it like partially submerged? Is it all above water? What's going on? It's partially submerged, and not very much of it is underwater. Actually, very little bit of it is typically underwater. The paddle wheel itself, most of it is above water. But at some point in our graph, when we go to sketch this out, you're going to see that your wheel will dip below water, so we're going to have some negative values here, and that's okay. Let's read through the clues, guys. We have this wheel, and it is 13 feet in diameter. The clue about diameter, remember that's all the way across the circle. This is a very important clue to graphing because this is the entire range. So what that means is if I look at the lowest line on my graph and the highest line on my graph, the maximum and the minimum, that should be a distance of 13 feet because that's the wheel. The next clue is a strange one. You guys have not seen this yet. If I tell you that this wheel revolves 30 times per minute, anybody know what that means? That's the frequency. Very good. And then, of course, there's more clues. It says that we're going to start from the very top. What does that mean? Good. You're going to be having a cosine graph. So I'm just going to go ahead and sketch what is likely to be a very ugly cosine graph, so I don't forget that this is cosine. They did that weird thing where they use H and T again. We'll come back to that. There's one more clue here. It says, assume that the paddle wheel is 2 feet below the water's surface when it's at its low point. So what could you label this point down, this line down here, if it's 2 feet below the water's surface? Good, that's a -2. So if you're below the surface level of the water, we call that negative whatever. All right, think really hard. How high up is the top of the wheel then? It is 11. How'd you get that? Very good. So the entire range from here to here is 13. So he's saying, okay, if you're -2 and then you add 13 to that, you come up to 11. He subtracted it, but same difference. So very good, very good. So the whole range here is the diameter of the wheel, 13 feet. Guys, I don't think I need to do any more on the graph. I'll show you why in a minute. Okay, let's talk about midline. I'll be honest, I'm really bad at visualizing midline when part of it's negative. Like, it's really hard for me to do. I think it's the dyslexia. So I refer to my formula for midline in this case. Midline would be max plus min in a quantity and divided by 2. Yes, I would rather have a decimal here than a fraction, so this is 9 divided by 2, so that's 4.5. And then I should be able to find the amplitude. Sometimes I can visualize it. This isn't one of those times, so I'm going to use my formula. So 11 minus -2 over 2. So that would be 13 over 2. Again, decimal is a better answer, so let's call it 6.5. And then there's just one more thing I have to find, and it's b. Now, on the previous examples, or the last example, we had to use the period length and did 2 pi over b, 2 pi over b, 2 pi over b. But wasn't there another formula for b? Ah, what if we use that one? What if we use the 2 pi times the frequency? Because didn't we know frequency? So that would be 2 pi times 30. And I want the prettiest answer possible for this, guys, so let's just call it 60 pi. Guys, I think we're ready to do this. A while ago, you guys talked to me about this being cosine because it starts at the top. They do that weird thing again where they want you to use h, so let's call it h equals, okay, amplitude first, which was 6.5, good. And then you said it's a cosine because it starts at the top. The b value comes next, so 60 pi. And then put a t next to that because they want to use t for the variable. And then plus, what's your midline? 4.5. Very good. So that is your formula. That's a very typical Algebra 2 question for this. So the paddle wheel, which we'll see in a minute, a Ferris wheel question that looks a lot like it. The high tide, low tide question shows up a lot. And pretty much that's it. So if you can kind of wrap your brain around those two kind of questions, you're in good shape. Let's take a look at a Ferris wheel, because who doesn't love a good Ferris wheel question? I know I do. So the last question was about a paddle wheel, guys. Paddle wheels will go below the water surface, and they'll go negative. Do Ferris wheels go below ground? Yep. I hope not. I hope your Ferris wheel does not try to go underground. In fact, does a Ferris wheel's wheel actually touch the ground at all? No. Like, if you look at the very bottom of a Ferris wheel, the wheel part, it's off the ground. Otherwise, it would drag on the ground and it would all break. So you're going to see some clues in a Ferris wheel question where they talk to you about, like, okay, the bottom of your wheel is actually so many feet off the ground. So be careful when we're graphing this. Now, I've been doing something where I just create my own labels on these axes. But what some kids do is they always call this axis 0. So, like, their Ferris wheel is going to be up here. I do that sometimes too. It depends on like which class I'm teaching, because some kids just do the problems differently. If you ever are looking at a key of mine and like you notice my Ferris wheel stuff is all like above the axes, that's okay. If you didn't do it that way and you just labeled your lines very carefully, we're saying the same thing. We're all going to get the same answer. The labels are what's important, guys. As long as you've labeled your axes, you're okay. All right, let's take a look at this Ferris wheel. It has, this time they tell me a radius of 20 feet. Well, a radius of 20 feet is halfway through the wheel, right? So if the radius is 20, doesn't that mean the diameter is double that, so it's 40? So keep that in mind if you're trying to relay this to a previous example that we just got done with. Okay, this operates at a speed of 3 revolutions per minute. What kind of a clue is that? That is frequency. All right, there's a clue down here that says the bottom car is 4 feet above the ground. Well, yes, I would hope it's above the ground, but it is 4 feet above the ground. And then they want me to write a model. There's one more clue they snuck in because we have to kind of be told where to start this graph. When t equals 0, the height is 44. So remember, we're measuring time along this axis. So they're saying when you start the problem at 0 seconds, I want your graph to start up here at 44. So what kind of a graph are they going to want me to use if it's going to start here at the top? Yeah, it's going to be another cosine one. Very good. Guys, I think we know this bottom line. Yeah, isn't it 4 feet off the ground? Didn't they say that at some point? And look at the range. Look at the entire range from 4 feet to 44 feet. Is that a distance of 40, which is the diameter of our wheel? Okay, so everything's kind of working out. I'm feeling good. I don't think we need to do any more work on the picture. I think we're ready for our formulas. First thing I'd like you to find is this midline. If you can see it and visualize it, you're awesome. I can't, so I need to use my formula. 44 plus 4 divided by 2, which is 48 divided by 2, so 24. And now I'd like you to tell me the amplitude, and if you could visualize it, awesome, awesome. I can't, so I'm going to calculate it. 44 minus 4 over 2. So that's 40 divided by 2, so that's 20. Hey, wasn't that the radius of the wheel? Yes, it was. That should match. And then last thing I need you to find for me, guys, is the value for B. So since they told you frequency instead of period this time, use that new formula for B, which says take 2 pi and multiply by the frequency. So a pretty version of 2 pi times 3 is 6 pi. There's B, here's A, here's K. A long time ago, you guys told me what this was. Is this sine or cosine? This is cosine. So again, they want you to use H and T. So H equals amplitude first, so 20 times the cosine. Stick B inside of there, so 6 pi times T, the variable. Oops, and then plus, what's our midline? What's our K? Plus 24. Very good. Nice job. Funsies. Yes, Mrs. Abruzzo, these are the most fun. I will go back. I am going to give you the homework, and I would like you guys to try to start it, even if it's just to kind of do some sketching. This is the last item in the homework check. We can still do some more of this on Monday, obviously. Yes. Are you the morning test? Like, when she just came in, she just got here, and they probably want, like, you probably didn't get to eat yet, did you? You did eat? Okay, well, that's good. So, halvesies, how about that? You'll be about halfway through the hour. Our test is Wednesday, yes. So we're going to be reviewing on Tuesday.
I can't do that on Wednesday.
What? Oh, wait, what day are you test? Hold on, let me, video done!